Good afternoon, physics students. Welcome back to the second part of the lesson plan. The video kind of cut off on the last one, so let's just jump back into it. As a refresher of what we were looking at, let's go back a little bit. So we were looking at modeling the situation with Clay Matthews as a kinematic equation. And oh man, is this difficult to do. But we're looking at Clay Matthews, right? We're looking at how he works, how he interchanges with Andrew Luck, and interchanges that motion as he hits Andrew Luck. So we're looking for the force of the impact or the hit that Clay Matthews makes on Andrew Luck. So let's dive back into it. We're going to take a look at our notes and we're going to say, oh yeah, that's right. We looked at how to solve for acceleration using the kinematic equation. Final velocity squared is equal to your initial velocity squared plus 2 times the acceleration times the distance. And so we use that equation knowing that our distance, using kind of anecdotal information, abstract, I pulled it from myself. In your situation, if you're doing tennis and you're talking about the impact of the ball, you'd have to measure and find out how long a tennis court is. And you'd have to cite that information. But for me personally, I happen to play football and I could use this kind of abstract information off the top of my head. However, make sure that you always cite your information that you use. We want to make sure that we're really modeling appropriate and good digital citizenship because people work hard to find this information, and it would not be polite of us to just take it and use it for ourselves as our own. Anyways, back into our lesson, we found the acceleration to be 13.67 feet per second squared. Woof. So we looked at it then. So we knew force is equal to mass times acceleration, and we had his acceleration as he made contact based on what we know about his top speed. We're guessing he could probably make it in that time, and that's another assumption. We're making tons of assumptions here, but these assumptions are all valid so long as they still point us in our goal and aren't just unique and don't happen to just fall into place when they need to. These are broad assumptions that we make and that we have to be okay with. So we go back and talk about mass. Now mass is not a force. However, weight is a force, and therefore mass and weight cannot be the same. So we plugged it into F equals ma yet again. Go ahead and thank Newton for that one. We plugged it in again to solve for what the mass was, and we took Clay Matthews' 240 pounds of weight force divided by 32.2 feet per second squared, which is also known as gravity. And gravity is an acceleration, and that 32.2 is in English units, whereas normally in metric units, you'd know that gravity is 9.81 meters per second squared. However, here we're in English units using pounds, and so we'll use the feet per second squared. So we did that. We took 240 divided by 32.2, and what it comes out to is 7.45 slugs. Now, slug is a unit of just mass that's in the English units, and is pretty much equatable to a gram, which is a mass unit in metric units. So we're going to think about it as just a mass unit, right? So we got slugs. But what does that mean? We now have Clay Matthews' acceleration when he makes contact, and we have his mass. So we can use that. We can use that to find the force of contact as he hits Andrew Luck. Well, let's take a look. We know that F hit is going to be equal to force. Is the force of the hit is going to be equal to the mass times the acceleration. Well, let's just plug it in. We know that F hit is equal to 7.45 slugs, which is what we have for Clay Matthews' mass, times 13.67 feet per second squared, his acceleration as he approaches Andrew Luck. Well, that comes out to a force of hit of 103.2 pounds. Yikes. That is a crushing blow. Not to mention the force of him falling on top of Andrew Luck as they go crashing towards the ground. Roughly at another 240. Woof. So that 103.2 pounds is the force generated by just his motion alone. Holy cow. Can you imagine what the poor guy standing there, Andrew Luck, is feeling when he sees 240 pounds of mass barreling at him? Well, it's that number right there. That's what he feels. So we have this information. We know how to describe the situation of Clay Matthews hitting Andrew Luck. So let's go back to ThingLink and use it. We're going to go back to ThingLink, and what we're going to do is we're going to click on this situation. We're going to go, yeah, right at that point of contact, right under Andrew Luck's armpit. We're going to say, boom, F underscore hit. And we're going to describe the situation. So we want to make sure that we type it out correctly. So F underscore hit is going to be mass times acceleration. Now we know that mass of Matthews is equal to 7.45 slugs. We know that A of Matthews is equal to 13.67 feet per second squared. Now we want to make sure that we always put our things out there and we describe our situations. So what does that mean? That means that F underscore hit is equal to, oh goodness, 7.45 slugs. We can absolutely put our units in there, and we should, to describe the situation to someone who doesn't know what's going on. If anybody is looking at this situation, we want to be sure that we describe it with the most clarity possible, because not everybody who looks at this is going to be a scientist like you and me. So let's just make it good on them. So we're going to say 7.45 slugs times 13.67 feet. Feet per second squared. Oh man. And what does that equal? That means that F hit equal to 103.2 pounds of force. Oh my goodness. And so we get to say, bam, yeah, we want to save that. So guess what our point is? So when it comes up, look at that. We have our situation there that shows the initial point of contact. However, the situation is not done, right? It's going to be your job to analyze the entire image to the best of your ability. Now, when I look at this image, yeah, there's contact on the hit, but there's also forces in other places. There's also a weight force of Andrew Luck crashing down that we're going to have to cite the information for. There's also a force of Clay Matthews coming down and hitting the ground with Andrew Luck, where we can combine their two weights and talk about their mass as it crashes down towards Earth and what that point of contact will look like. However, we do know that this is not the most accurate way that we can describe it. If we're to actually look into this from a strictly engineering standpoint, you're going to look at elastic collision, which is actually three-dimensional motion combined with elasticity, oh boy, and contact forces. And so these things can be modeled in all kinds of different ways. And the more detailed we get, the more accurately we can describe it. However, this is an accurate situation. So what we're going to do every time before we leave is we're going to save our image. Now, I want to go back to my profile and show you one that I have worked on significantly more. So we're going to go all the way back to ThingLink. And we're going to do this. We're going to click on my ThingLink that I have at the moment. Check that out. We got Andrew Luck statistics. We've got Clay Matthews statistics, followed by an explanation that we have on there. And make sure you put explanations. Now, you are going to turn in a supplemental note sheet that has all your calculations on it, and all they have to do is correlate. You don't have to write down how that all works. Maybe just color code or indicate what section or what bubble it goes with. Make sure you color coordinate or make sure that I understand the references. We have the hit. Now, make sure here is where we describe the hit made by Clay Matthews. But I want to make sure that we understand and tell people what's actually happening in that situation. So what that really looks like, this means that Clay Matthews is transferring 103 pounds of force to Andrew Luck generated just by his motion, not including the 240 pounds of force that come crashing down on Luck when it's over. Take a second and describe the answers that you get. If it's a big point, the biggest point of this image to me is Clay Matthews making that tackle. And so I want to give a little explanation for what I see as the big highlight. Now, you may add as many of these points as you want, but you don't want it to be overclustered. I'll attach a rubric to this assignment, and you're going to have the next week to complete it. You're going to have in-class time tomorrow, as well as in-class time on Thursday. We're going to make sure that we have this done. If you have any questions for me, please let me know. I really hope that this works out, and I really can't wait to see what situations you guys model. Remember that there's a lot of abstract information that we're taking, and a lot of situations can't be modeled ideally with kinematic equations of motion that we have today. But we're gonna make those assumptions the best that we can and describe that situation as scientists and take that critical eye. Now, I will know if you've taken a critical eye to it or not, and be sure you come and show me your image before you start on it, and I'll let you know if it's something that's possible or if it's maybe biting off a little more than you can chew. I hope this helps you all, and I can't wait to see you in class. Thank you.